we can combine Boyle's law and Charles' law into one law, which is so originally named the combined gas law. And I'm not going to go through how you combine those, but if you're interested, I'd be happy to show you. But the combined gas law is this right here. P1V1 over T1 equals P2V2 over T2. You can see that both of those laws are in there. Let me see if I can figure out how to do this. So if we get rid of that and that was Boyle's law, right? And if I get rid of the pressure, that was Charles' law. So this is just putting the two things together. Because sometimes the pressure, the volume, and the temperature all change at the same time. That's a more realistic scenario. So we're going to do problems with this combined gas law in the same way. We're going to read the question. We're going to make a table and write down numbers. So a sample of gas has an initial volume of 158 milliliters at a pressure of 735 millimeters of mercury and a temperature of 34 degrees Celsius. If the gas is compressed to a volume of 108 milliliters and heated to a temperature of 85 degrees Celsius, what is its final pressure in millimeters of mercury? Does that make your head spin a little bit? It's a lot of stuff. A lot of words, a lot of numbers. We're just going to make a table. So make a table. I'm going to have 1 and 2. And we're just going to go through and start writing things down. So the first number I come to, 158 milliliters. I'm going to write that down. 158 milliliters. And in Chem 20, we do not try to trick you. In Chem 1, we do try to trick you, just to warn you if you're going there. I'm not trying to trick you. The book is not trying to trick you. The test questions are not trying to trick you. So we write them as straightforward as possible. So initial volume, so that's a volume at a pressure 735. Those two numbers go together. Do you see that? This volume at this pressure, so I'm going to write down the pressure, 735 millimeters of mercury. That's a pressure. And a temperature of 34. Okay, so my table's not big enough. 34 degrees Celsius. What do I need to do to the temperature? Convert to Kelvin. So 34 plus 273. So that's 307 Kelvin. If the gas is compressed, so there are some words about things changing, to a volume of 108, so that's the new volume, 108 milliliters, and heated to a temperature of 85 degrees Celsius, convert it to Kelvin right away, otherwise you'll forget, 358 Kelvin. What is its pressure? The final pressure. So we filled out the table, we've got a blank. What are we going to call that blank? P2. Doesn't that work out nice? So we've been talking about each gas law separately. Of course, by the time you get to the exam or even just to the homework, they're all going to be jumbled up. How do you decide which equation to use? Well, make the table first and see what you've got. Here I've got V, P, and T, and they're all changing. So I need an equation that has V1, V2, P1, P2, and T1, T2 in it. So that's going to be the combined gas law. So P1, V1 over T1, P2, V2 over T2. Fractions, cross multiply, get rid of the fraction. I'm actually going to give myself some more space here. Because we're done with all that, and I need more space. So if we cross multiply, we're going to get P1V1 times the bottom of the other side, T2, is going to be equal to T2 times P, no. See, I made a mistake already. So easy to do. T1 times P2V2. And then look at that again. Okay, P1V1 times the bottom over here is equal to this bottom times that top. Now I'm trying to find P2. This guy right here, P2. So I need to get rid of his friends, T1 and V2. So I'm going to divide by T1, so that cancels out. I'm going to divide by V2, so this cancels out. If I do it to one side, I have to do it to the other side. So I have to divide this side by T1 and V2. I'm looking at this variable that I want to find. I want an equation that says P2 equals something. So I need to rearrange this. So I have to get rid of T1. I do that by dividing by T1. And I have to get rid of V2. I divide by V2. Because anything divided by itself is 1. You multiply it by 1, it doesn't change anything. And then if I divide this side by T1 and V2, I have to divide the other side by the same thing. That's all messy, so it's a good idea to rewrite it carefully. There's TV in there. TV. If you have V2 first and T1 second, that doesn't matter because order doesn't matter in multiplying, right? So if your variables on top end up in a different order, that's not a problem, but they need to be in the same part of the fraction, either the numerator or the denominator. So now I'm going to bring in my numbers carefully. P1 is 735 millimeters of mercury. And volume 1 is 158 milliliters. And then its temperature 2 is 358 Kelvin. And I'm dividing by T1, 307 Kelvin, times volume 2, 108 milliliters. Now it's a good idea to look at the units. Milliliters cancel milliliters, kelvins cancel kelvins. There are some times where the volumes might be ones in milliliters and ones in liters. And then when you go to cancel units out, you realize, oh, wait a minute, it doesn't cancel. So always check that. Now I'm going to multiply by the things on the top, 235 times 158 times 358, and I'm going to divide by 307, and I'm going to divide by 108, and I'm going to come up with a big number, 1253.9 millimeters of mercury. Anybody else get that number? All of the numbers that we're dealing with here have 3 sig figs, so we should round this And so that's going to end up being 1.25 times 10 to the third millimeters of mercury, rounded off. Now, if you ended up with 1,462,000, no, it's 14,625,571, you've got a problem with your calculator and how you're communicating with your calculator. Students generally don't have a problem with 735 times 158 times 358 divided by 307, but then you want to multiply by 108. Your calculator doesn't understand that. It's going to take all of this. It's going to take all of this. It's going to do all that math and multiply by 108, when what you really needed to do was divide. So if you're having problems where you're getting a different answer when we've got two things in the denominator, if you really want to multiply, then you have to put parentheses around these units. So if you have an issue with that, please come see me. I can best help you one-on-one with that. Any questions? It's the combined gas law.